Welcome to another screencast. This screencast is going to be about occluded fronts, and starting just like with the cold front and the warm front, we're starting with a textbook diagram of an occluded front. You can see the map symbols here indicate an occluded front. See, here is the cold front, and here's the tail end of another cold front, and the warm air is cut off from the ground, and that's when you have an occluded front. In order to talk about occluded fronts, we need to kind of do a quick little review of cold fronts. This is what a cold front looks like. Remember, heavy precipitation for a short period of time. The other thing we need to review is a warm front, light precipitation over a long period of time. Taking a look at the development of an occluded front, we're going to look at a warm front. We're going to introduce a cold front into the picture as well to show you how it develops into an occluded front. So right now we're not at an occluded front. Right now we're just looking at a warm front. And if you look, development of an occluded front, we kind of make that a little bit better. Development of an occluded front. See the color change? I think we could do better than that. Ooh, we did better than that. Look at that, huh? Alternating letters, because we're basically looking at, we need to look at a cold front and warm front together in order to see the development of an occluded front. So right now, through some digital wizardry, you can see there's another cold front. Now remember, this is the fastest part of the cold air is over here. This is the slower part of the cold air over here. So this faster part's going to catch up to the slower part, and the warm air is going to get cut off from the ground, and that's when you have occlusion. So the fronts are going to move, and you can see they all move to the right a little bit. The arrows are showing the direction of movement, and then what winds up happening is this cold front winds up catching up to the tail end of the cold front, and then that's when we have the occluded front. You can see the warm air is now cut off from the ground. It's not touching the ground. So any city located on the ground, which where cities are located, unless you have a tree house, but you have to be a pretty tall tree, and no, you know the story. So once the warm air is cut off from the ground, then we actually have what's called occluded front. Happens when two cold air masses meet and the warm air is cut off from the ground. That's when you have occlusion happening. So if you look at it from a map symbol standpoint, you would have continental polar air mass here, continental polar air mass here, and the symbol would be occlusion because over here in the air, up high in the atmosphere, you have warm air that's cut off from the ground. Hence, that's the occluded front. All right, and again, what it would look like here is the development of the occlusion. So here I have my cold front. Over here I have my warm front. I have cold air mass over here. I have warm air mass over here, cold air mass over here. What's going to happen is that cold front, and this is what it would look like from the side profile. So this is the map view. This is the side profile view. I forgot I had this in there. Then what happens is it starts to move. The cold front starts to move. So here we are, that cold front's moving. Side view that we already looked at. And then what winds up happening, see how this cold front moved? It's getting closer to the warm front. We're really catching up to the tail end of that cold air mass, slower air mass. And look, it starts to get closer and closer. There, we're almost occluded, but you can see that warm air is still touching the ground there. And then finally, we get occlusion. So you can see it's really catching up, it's almost there, and then we get occlusion. Then we have an occluded front. So, if you take a look at some other textbook pictures of this or diagrams of it, you can see here we have occlusion, and here it hasn't occluded yet. It's kind of like the zipper effect. So if you think about a zipper, if we pull the zipper down, this is going to occlude next and next and next. So the occlusion is going to continue on. A couple of various diagrams of it. Occluded front, warm air is cut off from the ground. Here's the occlusion happening. Here you would get kind of like the precipitation pattern of a cold front, heavy rain. Over here you'd get that kind of spread out rain, kind of like the warm front part. Right? When the occlusion first happens, that's when you get that heavy downpour. Here we have cold air, warm air. Therefore it's occluded because the warm air is cut off from the ground. Another same exact thing. You can see they talk about surface occlusion, which you don't really have to get that involved in it. But here's my occluded front, and then if I go up far enough, there's the cold front, and there's still the existence of the warm front there. Kind of a cool diagram, right? So you can see the heavier precipitation over here, and then it's more spread out, lighter precipitation at that end. And this diagram is pretty amazing. It's pretty cool. So here's my occlusion, and then you could see St. Louis, Indianapolis, Columbus, and Pittsburgh. and it's showing you right over here that they're all in the occluded front. They're all part of that occlusion front, but here it hasn't occluded yet. So that zipper effect will happen and we'll get occlusion over here. You can see they're set up over here and here. All of them are in a cold air mass. There's warm air above. Wish this was a tiny bit clearer, not as blurry, but you can see the development of the occlusion over here. So we have a mid-latitude cyclone over here, which we'll go over later on. And you can see cold front, and there's still warm air still touching the ground. We start to get occlusion. Occlusion's happening, and then you see that zipper effect. It gets zippered, and we get full occlusion over here. The whole front is occlusion. These things are enormous, these fronts. Absolutely enormous. And then this is just giving you another idea of how it develops from a mid-latitude cyclone into an occluded front. Another diagram, same Z's, right? You can see the occlusions developing here. We don't have an occluded front yet because that warm air is touching the ground. Once we touch the ground, you can see the heavy rain over here, and then it gets into a light rain once the occlusion happens more and more. And those two cold fronts, two cold air masses kind of blend together. And here's the last diagram we're going to show you about mid-latitude cyclone going into an occluded front. Now, you've earned the right for the next slide. Find him. Where is he? If you really want to challenge yourself, I made the picture smaller. So if you want to really challenge yourself and try and find Waldo there. And that brings us to the end of the occluded front. Enjoy your day and good luck finding Waldo. You could always rewind back to see this picture again if you wanted to. I really have no idea where he is. No clue. Not even a clue. I couldn't even begin to give you a hint.